coming. I guess after a really nice first day of the Ideas Conference, hopefully we'll have also another successful day today. So welcome to the graduate oral presentation session. Today we have 6 speakers. Each one is going to be talking for about 12 minutes, and then we have 3 minutes of questions and answers. Please, if the presenters, please be on time. Try to finish by that time. And the audience, if you have any questions, please, you're welcome to ask them. Now, our first presenter is going to be Reem Al-Masri, and her presentation title is Biodegradable and Neural Prosthesis. Thank you, Reem, and you're welcome.
Question. يتحرك. الو الو. Let me ask you a question. What does 1 billion mean to you? 1 billion is the number of Facebook users in the social media. 1 billion is the amount of money that Amazon's owner gets per month. Also, 1 billion is the number of people who are suffering from neurological diseases across the world. Neurological diseases includes Parkinson's disease, epilepsy, Alzheimer's disease, and seizures. So a common way to treat these diseases is using prosthetic intervention. When we talk about prosthetic intervention, we consider many issues, including signal resolution, surgical intervention, and host response. Signal resolution is when we want to record the activity of the cells from single cell. And surgical intervention is when we want to remove the device from the brain or the neural tissue when the device is not functioning. And for the host response is the inflammatory response when the device is not compatible with the tissue, or we have a mechanical mismatch. So our solution is about using or making inkjet-printed biodegradable device that is capable of measuring single-cell resolution. Our unique technology depends on inkjet printing. Inkjet printing is a technology that uses piezoelectric material and it changes shape when the voltage is applied. When the voltage is applied, the droplet of ink is ejected, and we can print some patterns. What is unique about this technology is that we can deal with low temperature materials, and we can allow a wide variety of materials to be used. And it is also it is suitable for multi-layer deposition. When we want to talk about signal resolution, it means that we want to record the activity of the neuron from a single cell. In order to do this, we need to use a microscaled electrodes. However, when we reduce the size of the electrodes, we increase the impedance, and therefore the thermal noise will increase, and we will get low signal to noise ratio. To solve this problem, we modify the surface of the electrode by introducing materials that enhance the roughness of the electrode, or we use materials that has electrochemical means which enhance the performance of the electrode. In our work, we target both the chemical and topographical approach by depositing layers of a biocompatible polymer called P.PSS. So this material it's commonly used, and here in our work, we showed how different layers of P.PSS will drop the impedance. So here we have different layers of P.PSS, and we showed how the impedance is dropping as we increase the number of the layers of the P dot. Not only this, but also the cyclic voltammogram, which is a measurement of the ability of the electrode to inject current, shows that the charge storage capacity increases as the number of P.PSS layers increases. The importance of using biodegradable materials comes from the need to monitor the diseases for a certain period of time without additional operations. So we want to have a soft conformal materials with no toxic effects and with less tissue response. This is important when we want to do a post-monitoring for the diseases without additional operations. In our work, we target the PCl, or polycarbolactone. This is a biodegradable material that has low biodegradability rate, and it can last for months. It also has a Young modulus that is considerably low. It is pretty close to the neural tissue. Here we have the brain tissue, which is in 1 kilopascal, and PCl is in the range of megapascal. Also, we compare it with the polyimide, which is a common polymer that is used in the prosthetic devices. So the PCl shows a very small Young modulus compared to the commonly used polymers, and this is enhance the mechanical match with the neural tissue and will reduce the inflammatory response. Also, since we are using a biodegradable materials, they have low melting temperature. So when we want to cure the printed patterns, we use a unique method called photonic curing. Simply, we use a camera flashlight to hit a pulse of light on the printed patterns. This will increase the temperature of the printed inks instantly and within a few milliseconds without degrading the polymer. Here we have SEM images where we have silver nanoparticles, which is the ink we are using to print the patterns, and they are not fused well. When we hit them with 2 flashlights, they are fused and they are creating the conductive path. To validate our work, we used the printed electrodes to record the electrophysiological activity of the retina from a rat. So we used a multi-channel system. We extracted the retina, and we put it facing the electrodes. And we were successfully able to measure a single unit activity from the retina, from the ganglion cells. In summary, this work has the ability to establish a unique prosthetic devices that are inkjet printed, biodegradable, and able to record the signal with a single cell resolution. The results lead not only to scientific publications, but also to solutions that can be clinically used and implemented as the future of neural prosthetics. Thank you. The type of the tissue that is interfacing with the electrode. Um, yes, definitely it affects the performance of the electrode because we have the Young's modulus of the tissue that is interfacing with the electrode, and the thickness of the tissue interfacing with the electrode all affects the performance. Yes, when we want to make devices, we target certain areas in the brain or the spinal cord or the neural tissue in general, and we study this specific area, and we create devices that are suitable for these areas. Electrodes. Okay. Okay. So basically, we have two types of recordings: extracellular recordings and intracellular recordings. When we use the electrodes, we are recording the extracellular action potentials. So the neurons fires spikes, and we want to measure the firing neurons. So what we did is that we printed the electrodes, and we connected them to the multi-channel system to record the activity. We extracted the retina from the rat, and we put the ganglion cells facing the electrodes. Okay, so since the electrodes are able to record the activity of the neuron, we got the single unit activity. These electrodes are in the range of 50 microns. So they are pretty close to the size of the neurons, and they are able to record the signal from one cell. Yes. They have a biodegradability rate. Yes. So what we do is that we do a biodegradability test to see if the weight of the material, which is PCl, is decreasing to a certain limit, which usually 60% of the original weight of the electrode. It means that it's not functional anymore. So when we do the biodegradability test in vitro before in vivo testing, we see the lifetime of the PCL, and therefore it depends on the overall lifetime of the device. Yes. Actually, actually, the tensile strain is not. It's going to affect the performance of the device, but at certain limit, we don't care about when the fracture happens. We don't care about the electrode if it's functioning or not. In the neural tissue, we don't have that much of motion and the forces that are affecting the electrode. So what we care more is about calculating the Young's modulus, not when the fracture happens. Yes. What?
Is it fueled by temperature?
Yes.
Okay, so why not put it, for example?
Interesting. This is because I mentioned that the polymer has a low melting temperature. For the PCL, it is 60 degrees. So when we want to cure the ink, we need 250 degrees. So if we put the overall device inside the oven and put 250 degrees, the PCL substrate will biodegrade and the pattern will be destroyed. So we don't want this. That's why we are using the camera flashlight. It's gonna increase the temperature instantly within few milliseconds, and it's not. This technique will not degrade the substrate. It's only will cure the ink. Thank you.
So, hello everyone. Today I will talk about the modeling of grain fragmentation in FCC metals using the continuum dislocation dynamics model. So the outline of the following presentation is as follows. First, a small introduction will be done on the basics of dislocations and the technique used in my study. Then the methodology will be described, which is based on the crystal plasticity model, and the results and final results and conclusions will be shown. So the objective of the following study is to understand the physical deformation during severe plastic deformation, and then to model the grain fragment refinement process during this severe plastic deformation, and finally to predict the microstructural properties of the phase center cubic metals. So as we all know, all metals exhibit crystalline structures under normal conditions. Metals can exist in one of the three main crystal structures, which are the body-centered cubic and the face-centered cubic, and finally the hexagonal close-packed. Repeating these unit cells would give us the crystal, and many of these crystals form the polycrystalline metal. However, by nature, the crystals always have some defects, such as point defects, vacancies, and self-interstitial atoms, linear defects, such as dislocations, surface defects, such as grain boundaries, and volume defects, such as pore cracks and foreign inclusions. So let's talk a little about dislocations, because it's the main contributor for the plastic deformation. We have two types of dislocations, the edge dislocation and the screw dislocation. The edge dislocation it's an extra half plane of atoms, which is situated above a certain line. We have the upper region will be compressed while the lower region will be tensile. The screw dislocation is formed by shear stress, where we have a distortion between the upper and the lower regions of the lattice. And we could have a mixed dislocation, which is a mix of these two types. So we will have edge and screw dislocations at the same time. So by subjecting material to a load that exceeds its yield strength, it will undergo a plastic deformation, and this plasticity could be seen as the permanent deformation on the macroscopic level. However, at the microscopic level, this can be seen as the movement of dislocations. So how dislocation moves? Actually, they move by applying a sufficient shear stress above a certain critical value. And this process is called the slip process, in which the dislocation, as we can see here, that dislocation A can move after applying this shear stress to from position A to B to C, and finally having an edge at the right surface. So this process also can occur on a certain slip plane and on a certain slip direction. So to achieve this plastic deformation, some mechanisms can be, or some techniques can be applied. One of the methods is called the equal channel angular pressing, where a billet is pressed by a plunger. This process is one of the thermomechanical processes that improves and enhances the mechanical properties. We press the billet between two channels intersecting at a certain die angle phi. So what happens is we have a simple shear at the intersection plane here, and the grains will fragment, and we will have a drastic decrease in the grain size. Also, several passes can be repeated. And now we will see some microstructural properties that are affected by the ECAP. We have the grain size. We can see here that the initial grain size is reduced from 50 to 1.6 micrometer just by pressing it one time. And it's known that when we have smaller grains, that means higher strength. Another feature that's affected is the texture. The texture is the representation of the orientations of the crystals within the polycrystal. So the ECAP can orient or reorient the ideal orientations of the lattices or of the crystals inside the polycrystal. So in order to proceed with our modeling, we use the crystal plasticity model, since it captures larger strains and large and severe plastic deformation. And this crystal plasticity model is coupled with continuum dislocation dynamics to capture the dislocation density evolution within the crystals. Also, in order to average the response, a Taylor-Lin scheme is used to average the stresses inside each crystal, and also it's assumed by Taylor that the deformation gradient at the micro scale associated with each grain is equal to the macroscopic deformation gradient. And here we have some constitutive equations. So to go into our details, grain fragmentation model, some assumptions are taken. First of all, we assume that each grain in the polycrystal, this schematic represents the polycrystal, and each color represents a different orientation for the crystal. So each grain is assumed to have a square shape, and each grain is assigned a position and orientation, grain size, and it has 4 neighboring grains that will affect its deformation. So in order to implement the grain-grain interaction, which will affect our fragmentation process, a concept called the GND, or the geometrically necessary dislocations. These dislocations are accommodated at the grain boundaries. So we'll have on the grain boundaries geometrically necessary dislocations that will hinder the rotation of the boundary during deformation. So how this effect will be implemented? First of all, we take 2 calculation steps. The criteria to grain fragmentation occur is by having a misorientation angle between the center of the grain and the boundary of the grain. So when this misorientation angle exceeds a certain threshold value, the grain will split into 4 new grains, and these new grains have the ability also to split more and more. So how this misorientation angle is calculated? First of all, we took 2 calculation steps. In the first one, we have no grain-grain interaction. That means the GND effect is not accounted, while for the second one, we account the geometrically necessary dislocation effect. So this effect, in each case, we calculated the misorientation angle between neighboring grains, and the difference between them is our misorientation angle that will decide whether the fragmentation will occur or not. Here we have a schematic figure where some grains could undergo fragmentation while other could not. And here for grain I, for example, we have, it will have more grains neighboring it. This will increase its G&D density and it will increases the possibility to fragment with further deformation. Finally, in order to calibrate our model parameters, we have some model parameters that needs calibration. Torsion experiments were extracted from the literature, and we compared for the same material, of course, and we compared we fit our model with these data, and we get our model parameters with the best fit. Okay, some of the model predictions is the texture, which is the most important, is one of the most important features of after ECAP. So we have a very good agreement between the experiments and our model. These are the experiments and these are our model for 2 passes. And here we have a small video that represents the evolution of the texture with deformation. And as I mentioned, this texture represents the orientation of the crystals within the polycrystal. And finally, other important predictions are the grain size. We can see that we have very good agreement between the experiment and the model. We have 1.2 micron for experiment and 1.3 for our model, and so on. Also, the dislocation density evolution can be predicted by our model. In conclusion, the proposed model combined the Taylor-Lynn, the crystal plasticity, the continuum dislocation dynamics, and the grain fragmentation model to predict the behavior of FCC metals during ECAP. And the model parameters were calibrated using torsion experiments for copper, and the model captured the main microstructural features of ECAP after 2 passes. And thank you. Actually, we have this billet when it's pressed, its cross-section is not affected, so we can strengthen this billet or this sample that we need without affecting its geometrical shape. However, its strength will be drastically increased, doubled or tripled, but this will affect its ductility. The ductility would be reduced. So the application is for the same material that you need to use in industry or other applications. It could be E-capped, and we will have improved properties. Yeah, of course, for all metals. However, for some metals, it have some restrictions since it would fracture, such as HCP metals, since it has, it needs to be processed at high temperatures, not fracture to occur. مش الحال هي مش الحال.
So, should I start? Okay. So good morning. My name is Zana Habli, and I'm gonna present my work, which is entitled as Biomimetic Sulfated Glycosaminoglycans Maintain Differentiation Markers of Breast Epithelial Cells and Preferentially Inhibit the Proliferation of Cancer Cells. So glycosaminoglycans, they are polysaccharides that are present in the extracellular matrix, and they play vital roles in modulating the cellular behavior, mainly through binding to cell surface receptors or by binding to growth factors and inhibiting or allowing the cells to proliferate. They play their role through the sulfation arrangements, which are sulfate groups that are present in their backbone. And we refer to these sulfation arrangements as sulfation codes, and they affect the memory development and diseases, mainly breast cancer. Unfortunately, unlike proteins and lipids, it's very hard to extract these glycosaminoglycans and categorize them according to their sulfation patterns because they are extremely heterogeneous. So we thought, what if we have something that could mimic these glycosaminoglycans with specific sulfation arrangements and use them to study the development of the memory cell and see their effect or assess their effect on cancer cells. For that, we were very lucky because we have alginates, which are polysaccharides that are extracted from the algae that are from brown algae, and they have similar backbone to the glycosaminoglycans. We added sulfate groups to them, and we will be referring to the sulfation patterns as degrees of sulfation that will be ranging between 0, 0.8, 2.0, and 2.7. And we're going to use a positive control, which is heparin, that is a naturally occurring glycosaminoglycans with a degree of sulfation 3. So it's maximally sulfated. And we're going to assess their effects on two cell lines, the normal S1 cell lines and the T4 cancer cells, using two models, the 2D monolayer culture where cells are grown in plastic, or the 3D model where cells are grown in hydrogels. Why did we use the S1 and T4 cells? These two cell lines are very special because the S1 cells, when they are grown in 3D, they tend to form SNR-like structures that are similar to the SNI that is present in the human body. They mimic it through the lumen formation, the size, and the distribution of polarity markers. On the other hand, T4 cells, they are the descendants of the normal cell lines, which means they are the perfect cancerous counterpart to our cell line. And they have a very interesting feature, which is their capacity to revert to the normal phenotype when they are mechanically compressed or when they are enzymatically or by antibodies, they are inhibited. Some of their receptors are inhibited. So let's start with the 2D results. We grew these cells in a monolayer, and then we added sulfated alginates on them, and we counted the number of viable cells and dead cells. As you can see, alginate sulfate 2.0 had the most potent effect when we compare it to the untreated control or to the pure alginate that is not sulfated. The effect was more potent in the T4 cells as the number of viable cells decreased by half. Then we moved to the 3D model, where we added the alginates early in culture, which means we are adding these alginates pre-lumen formation compared to the S1 cells. And again, alginate sulfate 2.0 had the most potent effect as it decreased the diameter of the SNRs that we had. The number or the count or the frequency of small SNR increased while that of the large SNR decreased. And the effect, again, was more potent in the T4 cells as those of sizes 30 to 50 micron increased dramatically compared to their normal. We wanted to see if these alginates affect the capacity of the SNR to form lumen, and fortunately, it did not. So all the cells with all the conditions were capable of forming lumen, but some of the polarity markers were redistributed from apical side to basal side and apicolateral side, both beta-catenin and SCRIB, which are polarity markers that are commonly tested in these cell lines. But in real case scenario, if we want to use these alginates as drugs, the SNR will be fully developed. It will have lumen. It will have polarity markers that are properly distributed. So it does to make our theory more comprehensible, we decided to add these alginates post-lumen formation to mimic the physiology of the body. And to our luck, the sizes of the SNR did not change at all, and the polarity markers were maintained. A very interesting result we're recently getting is the reversion of the T4 cells. They are forming these flowery-shaped SNR. They are having proper distribution of the polarity markers. I'm not really sure the image shows it properly, but it does. And finally, we're talking all the time that these alginates are preferentially reducing the proliferation of the cancer cells and not the normal cells. So a co-culture system was a perfect approach for us. We cultured S1 cells, and we added on them T4 cells that are GFP labeled. GFP means green fluorescent proteins, so they basically fluoresce under fluorescent microscope. And we counted the number of cells post-treatment. The number of S1 cells, the yellow bars, were consistent throughout. But the number of viable cells in the T4 decreased dramatically, mainly with the alginate sulfate 2.0. So in conclusion, our findings suggest that our engineered biomimetic sulfated glycosaminoglycans, they preferentially hinder the proliferation of breast cancer cells while maintaining differentiated polarized S1 cells in 3D culture models. And this novel biomimetic approach will enable us to develop potential anti-cancer drugs that can be used in treating breast cancer. I'd like to give my acknowledgement to my professors and some of my lab colleagues, and the CRS grant for funding this work, and the CRS for allowing us to use its facility. And that's it. Thank you.
What I want to get from my question is, why do you think these alginates are having that effect? What's the mechanism behind that?
Okay.
It seems. So why did you decide to go with them versus something else? And also, just a second question: did you have pictures of the 3D hydrogel? Have you quantified how these alginates actually spread around in that culture?
So we're not using the alginates as a hydrogel, although they do form, they have the capacity to form hydrogels. We used regular matrix gel, where we added the cells on top of it, and then we added the alginates in suspension. So we're not using a hydrogel system of alginates.
It's only actually, it's not actually a hydrogel.
No, it's not. It's not
on top. So
yes, exactly.
Not necessarily 3D, right? So it's more of.
No, it is 3D. The cells, they tend to grow. Let me go back to. So this is the control, and these are cross-sectional areas of the cell taken through confocal microscopy. So we're just seeing, the sphere we have, we're cutting it in half, and we're seeing what is in there. So it is 3D. The cells are grown in 3D, but the alginates are added in suspension.
You're hoping the alginate diffuse through the.
Exactly.
Yes. Get to
yes. Concerning the first question, which is the mechanism of action, I added a couple of slides that might help us. So, alginates, we said that the alginates, they tend to either bind to the cells, or they tend to bind to growth factors and starve the cells to death. So we use this QCDM analysis, which is the quartz crystal microbalance, where we have a gold sensor, and it resonates or oscillates over the resonating quartz. And we deposited layers on it. So every time we deposit a layer, the frequency drops, which corresponds to the mass that is added. We immobilized alginates on the top of it, and then we added some of the growth factors we use in our cell culture media, like insulin and epidermal growth factor. The blue curve represents the drop in frequency. So when we added the alginate, let's say, it got deposited and immobilized, so we had a drop in frequency. But when we added insulin and EGF, we did not see any drop of frequency. So we can say that these alginates are not binding to growth factors and starving the cells. from this approach. We're currently performing some ELISA experiments to see the binding.
You showed with this, so go through this again. How do I, from this, tell that alginate can actually affect cell growth?
No, from this one, if we had a decrease in insulin, and when we added insulin, if we have a decrease in the frequency, it means that the insulin is binding to the immobilized alginates. So probably the alginates are sequestering these growth factors and starving the cell. This is what I'm saying. Yeah. But from here, you cannot tell it's doing this because we didn't get any result.
The mechanism action is still not clear. Some indication in this.
Okay, so another approach is by labeling the alginates with fluorophores like FITC and imaging the cells, taking images of the cells to see whether they are interacting directly with the cell or not. We weren't capable of tagging the sulfated alginates yet. We only tagged the pure alginates, the sodium alginate, and in 2D you can see that the alginates, the green spots, are all over the cells, and in 3D they are binding to the receptors of the cells, and in some cases they are being internalized, as in here.
What did that show?
So
how does that go to mechanism action?
No, it's an approach that we're currently proposing to study the mechanism of action. Yes, it is it's ongoing. Yes.
Not my area, but I would like to. The effect of the alginates sudden?
Sorry?
Alginates effect on the cancer cells?
No. We checked the effect post 24 hours of exposure, 48 hours of exposure, and 72 hours of exposure.
What you reported
Is in 72 hours.
happened after a week or 2 weeks?
We didn't see the effect, صراحة. This is not commonly used in cell biology. You only check for 72 hours, maybe 4 days at maximum, because the cells won't be able to withstand being cultured for that long period of time. That's it. Thank you.
We're going to have a coffee break now, and then we'll regather afterwards, about 15-minute coffee break. So now it's Reem Brom from the Electrical and Computer Engineering Department.
Good morning. I'd like to take this opportunity to thank you for granting me with a chance to talk about my research. The title is Studying the Effects of Driver's Distraction Caused by Different Formats of Digital Billboards. My thesis advisors are Professor Awad and Professor Ma'dieh. So this is the outline for the presentation. So let's start off with a brief overview. So the World Health Organization declared in the year 2017 that car crashes is the leading cause of death for people aged between 15 and 29 years old, and that in year 2017, 2.25 million human lives were lost because of car crashes. So the National Highway Traffic Safety Administration reported that 78% of these car crashes involved some kind of driver distraction. Now, the Lebanese internal security forces also reported that the leading known cause of car crashes in Lebanon involved some kind of distraction as well. So in our research, we are studying the driver distraction caused by digital billboards. So these are some images of digital billboards that you might have recognized, placed in the streets of Beirut. So now we're going to state the objectives of our study. So number one, we're going to analyze the effects of different types of digital billboards on drivers' performance and attention. Then we're going to detect drivers' distraction caused by these billboards using machine learning, unsupervised machine learning, using sensors which include driving performance, eye tracking, and EEG. Last but not least, so at the end of the day, we wanted to propose a intellectual merit, which is to improve eventually road safety by giving recommendation for policymakers to regulate or control how digital billboards are placed. So going back to prior literature, so what is the definition of driver distraction? The ISO defined driver distraction as paying attention to something that is unrelated to the task of driving and could impair driving performance. So throughout the literature, we can find many definitions for distraction. The National Highway Traffic Safety Administration categorized 3 types of distraction: the visual distraction, manual distraction, and cognitive distraction. So visual distraction is having the eyes off the road. Manual distraction is caused by having the hands off the steering wheel. And finally, the cognitive distraction is being mentally unfocused on driving and thinking about something unrelated to driving. So previous work on driver's distraction focused mainly on a distraction that is caused from within the vehicles, such as using mobile phones, navigation systems, talking to passengers. Less consideration is given to distraction caused by the outside environment of the driver. So that's why we are focusing on digital billboards causing distraction. So previous work, so this table summarizes some of the related work that we investigated in terms of driver distraction and billboards. Excuse me. Okay, so in terms of driving distraction using multi-sensors. So using multi-sensors, so what we're using is driving behavior and visual behavior and EEG. And we also intended to increase the number of participants and to study more types of advertisements. So here we can see also other related work that have studied digital billboards and their effects on driving behavior. Okay, so the methodology that we've used, first of all, we had to recruit participants, in that end we recruited 100 participants from AUB, students, faculty, and staff. Obviously after getting the approval of the IRB, so these are the criteria for recruiting the participants. Second of all, the experiment strategy. So the experiment setup was made up of the a driving simulation system, the eye tracking device, which was placed on the dashboard, and the 14-channel EEG headset. So this was the scenario that the drivers had to drive through. We included 27 different types of billboards, 9 static billboards, 9 transitioning or changeable billboards, and 9 animated billboards. And these billboards were controlled in a way that the driver would see one billboard at a time. So the independent variable here in our study is the format of the billboards. Whereas the dependent variables were the performance metrics, eye tracking metrics, and the EEG. So for the driving performance metrics, we've used average speed, average acceleration, deceleration, average deviation from the center of the lane, and average reaction time to traffic lights where the billboards were placed at the intersection. For the eye tracking, we've used average percentage of fixations on the road, average percentage of fixations on the DBA, which are the billboards, the average fixation duration on the billboards, and the average number of gazes on the DBA. So what we mean by the average number of gazes is how frequent the driver was looking at the DBA. So for the EEG metrics, we've used EEG band powers, which throughout the literature have shown that they have been related to distraction. So now I'm gonna present the summary of our findings. So in terms of driving performance results, the speed, acceleration, and deceleration were not affected by the presence of the DBA. So this implies that the drivers did not necessarily have to slow down whenever they encounter a billboard. However, when it comes to the deviation from the center of the lane, and the reaction time to traffic lights, we find that the animated billboards cause the most impairment in that sense of the driving performance. Following that were the transitioning DBAs. Now moving on to the eye tracking results, we've seen that the metrics that we were evaluating did show statistical significant differences for each type of billboard, with the animated DBAs leading to the highest visual distraction, except when it came to the average number of gazes of the DBA. So here we can see that transitioning DBAs caused more frequent gazes at the DBAs. So this showed us that the drivers were looking at longer durations at the billboards, but they were looking more frequently at the transitioning billboards, maybe checking how the billboards are changing. Now in terms of the EEG results, so the results that we had, it was that the theta band and the low beta band both are related to driver distraction. The differences were not much accountable. This could be due to the fact that the experiment did not cause a very high workload. So otherwise, if we had like a higher workload, maybe asking questions to the drivers while they were driving, we might have got better results at the EEG. So now moving on to trying to classify distracted and not distracted. So what we had to do is to separate the data, each type of billboard by itself, and we used the principal component analysis to try to get rid of the correlated features. So we ended up with the principal component 1 and principal component 2, which explained about 98% of variability of the data, of variance of the data. So, and then we used the K-medoids for clustering techniques. So in the 3 cases, we can obviously, like visually, we can see 2 clusters, 2 different clusters. So these clusters could be used as classifying distracted versus not distracted. So finalizing with the contributions to our research, we got a better understanding of the impact of different formats of DBAs on driving performance, visual attentiveness, and EEG dynamics. In terms of policy making, we could conclude that policymakers, well, in some countries, they don't have a lot of regulations for billboards that are placed at the road, but we need to point out the fact that the animated and transitioning billboards should have a special treatment and not be treated as normal static billboards, as they cause more distraction. So they shouldn't be placed, for example, in highways and places that have high pedestrian crossings, such as schools, universities. And at the end, we used unsupervised machine learning to classify between distraction and not distraction. So this way, we allowed the data to speak for itself instead of setting rules or labeling the data or setting a criteria above this point. It should be classified as distraction or not. So we used the unsupervised machine learning technique so the data can speak for itself. Thank you.
All right, thank you, Reen. Any questions?
Thank you very much, Reem, for your presentation. I just want to ask you about the EEG. So
Yes.
the theta energy band, or all the different energy bands, they're quite non-specific in general, because I guess you can't really tell what's causing it. So what makes you believe that the theta energy band is an indication of distraction? Because I guess I could be stuck in traffic and getting agitated, my theta energy band might increase. So how are you going to deal with that kind of thing? So the sensitivity of the
So this is why we included other type of metrics within, other than the EEG. So we included the performance and the eye tracking data to combine these features in order to do the identification or the classification of distraction or not distraction. Throughout the literature of this work, they've used the theta and in combination with the low beta band to detect distraction or also detect high workload. So we can't say that the theta band by itself can be indicative of whether the driver is distracted or not, obviously.
Do you have an idea about the sensitivity and specificity
Yeah.
of the combination of those? Like, is it quite sensitive and specific if you combine the eye tracking with the EEG data, with the performance data?
So this was done in my thesis, but I didn't show it in the presentation. So obviously there was sensitivity, so different types of identification or classification of distraction versus not distraction. And we've used different types of labeling the data and using supervised and unsupervised data. But we thought that it was interesting to see how the unsupervised learning by itself sort of categorized the data by itself instead of like setting rules in terms of sensitivity and so on.
So we don't have the stats for it, like that. You don't have the numbers at the moment.
Yeah.
That's okay. I'll just a second question while I'm here. So you've conducted this in the lab,
Yeah,
right?
at the transportation lab here at AUB.
So what do you think is one of those limitations of doing it in the lab compared to doing this externally, where digital billboards might be placed
that's
a
very
lot more
interesting.
laterally or a lot more...
So let's state first of all the advantages of using a simulated driving. So obviously it gives us a better controlled experiment. Like I could set the scenario so that the DBA is by itself. There is no crossing of pedestrians, nothing else that could cause him distraction other than the fact the DBA is there. So naturalistic driving is obviously would be a second step. However, like the controlled experiment should be the doing the naturalistic
It gives
driving.
you a lot more control to do this in the lab.
Exactly. So you get more control when you do it at the lab.
But just in terms of the digital science, I mean,
Yeah.
because we can get an idea of how they actually look.
Okay.
So are they looking at this screen, like is it just a screen that's lateral in front
So,
of them?
so I didn't mention this in the presentation. So the billboards were controlled in a way that only the format would affect the distraction or not distraction. For example, they were made the same size. The same color palette was used in all the billboards. There's a background of white color behind all the billboards, and they were placed to the right of the road, and equal distances between the billboards. So the animated billboards were sort of not like very animated as you would see in the roads today. So it included like a very swift movement, like for example, a car that's moving back and forth. Something that's very simple. So this would show us that this simple movement did show this distraction. How much more if you would see a full animated billboard on the roads. So this is also this answers your question versus naturalistic driving.
I mean, just in terms of how is it actually a screen they're looking at in the billboards? Or is it you're placing real digital billboards?
You. So basically, if this is the road, you would see in the screen there's like a billboard placed.
Okay, I understand. Now I saw that.
Yeah.
Okay, thank you.
So what did you use as your control? So you mentioned, for example, deviation from the center
Yeah.
of the road. Was there a group that went through the simulation with no billboards?
Yeah, so the control was, so all of the participants, they drove through the experiment. There were locations where they did not see any billboards at all. So this was the control that we used.
So the same people at the experiment
Yeah,
were
exactly.
subjected to different...
Yes. So all of the participants went through the whole scenario that included the 27 billboards.
And this looks like an urban setting.
Yes, it is an urban setting.
Do you have like a mode where they can be on a highway, for example?
Yes, we can control that, but I didn't include that in my studies. But we can, through the software, you can determine which type of road do you want to include in.
Because I would imagine, I mean, distraction would be higher in an urban
obviously.
setting than a highway.
Yeah.
Any other questions?
Thank you very much for this talk. It's very interesting. Did you do any tests on daytime, like if it's night or day?
Right. So obviously, as we said, that it was a simulated driving, so we only included daytime. But it would be really interesting to see the nighttime and the daytime. So this is one of the limitations of the work that so one of the most distracting things about billboards are their brightness during night. So unfortunately, we were not able to study this because of the limitation of the instrumentation that we have.
Thank you.
Welcome.
Hi, thank you for your presentation. Just a quick question. Did the drivers know that the billboards are coming?
No.
Do you consider the actual social sense of driving in Lebanon versus other countries? Because one of your metrics was running at a red light, and I see no one here on the road actually, pays attention to that. Does that factor in when you're trying to publish this data? You say, well, this is coming from,
drivers
in the
that
Middle
drive
East.
in Lebanon.
Yeah.
So so we did a questionnaire before having the drivers do the experiment. So we asked them if they've driven anywhere else in Lebanon, but this wasn't included in the analysis. But it would be very interesting to include that. Welcome.
I think the computer would handle it. Yeah, being in Lebanon. All right, thank you. Ali here. So our second speaker is Ali Ghaddar from the Architecture and Design Department.
Okay, where's IT? Yeah, okay. So, my name is Ali Ghaddar. I'm from the Department of Urban Planning Policy and Urban Design. So, I'm gonna introduce performance-based planning and participation in the context of rapid urban transformation. The case of Mar Mikhail neighborhood in Beirut. First of all, I would like to say that the urban transformation in the city of Beirut, it's not just taking part at the level of the neighborhood, but also at the level of the municipal Beirut and greater Beirut. So this slide shows the macro characteristics that impact transformation, such as political context, economic context, housing policies, and urban regulations. So the amendments, for instance, in the building regulations, it impacted transformation not just at the level of the neighborhood. So what I'm doing that I'm questioning available urban regulatory tools and their capacity to produce a qualitative neighborhood that can challenge issues related to urban transformation. So for that reason, I took the case of Mar Mikhail. So I started to investigate what kind of urban planning tools we can adopt that can challenge urban transformation. So this is the neighborhood of Mar Mikhail. So just look now quickly to the image to see the neighborhood and what's happened until 2018. So going back in 1936 until 2018. A huge transformation took part not just at the level of the neighborhood, but also at the level of the city, the expansion and transformation. So we can see that before the location of the tramway, it's the same location of the ODL. So this is in the box here, it's the Mar Mikhail neighborhood. Looking from the lower part of the neighborhood till the upper part, we can see the mushrooming of the new developments, the real estate development. So I was exposed to Mar Mikhail through by the urban planning workshop that we did, and it's a course we take in the department. It's like 6-credit course over one. So we do like a documentation of urban form and structure. We do historical evaluation of the area, mapping urban morphology, social makeup, local business, real estate market, main stakeholders and actors. Then we do the analysis, the vision, strategy. But in what we were exposed also to participation. So we did within the workshop, a workshop mitigating gentrification through participatory planning approach. So what we did, we went to Mar Mikhail and we did like focus groups, we got the issues, and we did the vision, the objectives. and then the development principles. What's happening in Mar Mikhail? So I did these maps. It's like pixelated maps to see transformation in the sense of density. So we have degradation of social networks resulting in changes in socio-spatial practices. So we have evictions, displacements, and abandonment. 15% of the buildings are either fully or partially abandoned. So these at this level. Let's go to the economic sector. So we have decay of traditional economic networks resulting in changes in local economic sectors. So we have like 69% are new economic enterprises. They are pubs, ACDs, restaurants. So 31% just are old businesses. So we also have loss of clientele and deterioration of old businesses. Regarding the real estate development, what's happening? We have reinvestment of capital through land, resulting in changes in the built environment. Okay, what the graph shows that from 2007 till 2017, we have 63 permits. The majority of these permits are demolition and for new developments. Okay, so I'm questioning the logic of the Lebanese regulatory framework here. So we can see that these tools in Lebanon have been here since the 50s, put in place during the French mandate, inspired by the French. And even France now itself moved away from these tools. They shifted, and we are still working on the same tools. So the rationale was, in all the amendments and the regulatory framework, was to maximize space of the development and in order to maximize profit or capital. Okay, so what I did in my research, I searched or investigated case studies that get away from a prescriptive rigid systems and adopted the qualitative performance criteria and objectives. So the criteria behind my case studies was, I went abroad and investigated the performance approach, where the performance code is not related to the building itself. However, it is related to other criteria such as livability, inclusiveness, character, effectiveness of the neighborhood. What is performance-based planning? It's like a policy instrument. First of all, it's a policy-based intervention, not a direct-based intervention. So it's a policy instrument. One of the policy instruments is regulations. So it's an urban planning regulation. So we use it to regulate market and the built environment. So in regulations, we have two: either the perspective, which all cases to meet predetermined norms, or consider each cases on each merits, which is the performance-based planning. So the performance-based planning approach allows flexibility and innovation in planning and development regulation. It focuses on the outcome premises and desired end results. Here, planning schemes must respond to a particular outcome rather to a predefined norms or standards. So this approach is important because also it allows a greater dialogue among different stakeholders and participation in the decision-making process. So when we say about performance-based planning, we have a performance code. What we mean by a performance code? So the performance code, first of all, we start to perform not just the building itself. We can start to perform neighborhood planning, physical infrastructure, stormwater management, streetscape, neighborhood character, site planning. In the site planning, we can perform site planning, lot layout, street setbacks, building envelope, private open spaces, safety and security, design or climate. So we start to perform issues that not just about the level of the building, like more about livability and even inclusiveness of the neighborhood. So this is the code itself. What is the code? For instance, if I need to perform site planning, first pages of the code of this site planning element, it like provide a background information, it clarify principles and demonstrate best practices. Going to the code itself, we have the intent. The intent, it reflects identified planning and policy requirement. So if we have a development, the development must conform to this intent. We have then the performance criteria and acceptable solution. The performance criteria, it's a general statement of the means of achieving the intent. And it provides designers and developers with an opportunity to develop a variety of design responses. So we have a set of acceptable solutions. And here it comes how it is innovative and flexibility. So this is another code, the same, what they are performing livable neighborhood, physical infrastructure, stormwater management, environmental and cultural protection subdivision of buildings. And this is in the second part, this is the code, the element, like they are performing livable neighborhood. This is the policy. We have the performance criteria and acceptable solutions. So in the best practices, we have the zoning code. The zoning code, usually it's about lot subdivision, use bulk density design. And in the building code, the best practice, it's like the IBC International Building Code. It deals with structure, fire, egress, accessibility, light, ventilation. شو عنا بلبنان? In Lebanon, we have something named zoning code. The zoning code, it deals with use and density. It's like the FAR and the floor area ratio. So it's like just about how to maximize space and density. In the building code, it deals with bulk, light, ventilation. In the bureau technique, we have mandatory technical check. We have structure, fire, egress. And we have a planning code which deals in lot subdivision and land pooling. So what I'm introducing that the building code must shift only toward the international building code, which is structure, fire, egress, accessibility, light, and ventilation. And I'm introducing a performance code where we can perform all of these stuff based on the vision that we did in the neighborhood. So then after I did all of these studies, I returned back to Marum Khail. So the challenges that could be, after doing my case study analysis, I returned back to Marum Khail. I tried to identify the challenges that could be raised by the potential implementation of performance-based planning approach. First of all, it requires a reform. هلا نحن كلنا عم نحكي عن reform. So it requires a reform. It requires to start thinking about the urban governance. At what level really we gonna introduce performance-based planning? At the national level, regional level, at the local level, and especially that the performance-based planning, it requires to start thinking that we need to introduce a neighborhood level, to start performing planning at the neighborhood level. So, okay, if we have then I start to, if we have a vision, how we get to performance criteria or this performance-based planning. So first of all, we do inventory, which I worked in the workshop. We identified the trends, indicators of transformation. We did advocating planning bottom up through the participatory planning. Then we did the vision. Then we do a neighborhood plan. A neighborhood plan, the neighborhood plan specify the future developments in the city. Okay, it's like something like strategic plan, but at the neighborhood level. So here we need to introduce additional level in the existing spatial planning, which is the neighborhood level. Then we go to the performance planning. We do we have the development principle. We do the performance scheme, as I said before, and the institutional framework. Institutional framework regarding who gonna write these. The institutional framework regarding the this neighborhood plan, and then regarding the performance planning code. My study paves the way, just to say finally that my study paves the way for a major transformation in the philosophy of what should be regulatory planning in Lebanon. So performance-based planning is an opportunity to how the city can perform not just at the level of the building, but also at the built environment livability on all of these stuff. Just drivers of performance approaches, why we started to shift to performance approach, because really there is the prescriptive zoning failed to respond to today's problems, including the competing pressures of complex issues, such as environmental concerns, decaying infrastructure, suburban sprawl, shortage of affordable low and middle income housing, and quality of the built environment. The advantages of my approach is it allows flexibility and innovation in the planning and development regulation. And it's flexibility in terms of planning scheme, formats, and content, flexibility in achieving the desired end results, because flexibility in terms of how planning and development are regulated at the local level. It's more concerned also with the impacts of the effectiveness of the development as per performance criteria. It's really introduced participatory planning in the decision-making process. Finally, a lot of theorists say that it's capable of achieving sustainability. Thanks.
Thank you, Al. Any questions?
gave an example about Mar Mikhail.
Yeah. Okay, if you need to study the evolution of Mar Mikhail in the past decades, what happened? What happened in starting from 2007? It was really, it's a shift, gentrification takes place. What we mean by gentrification? When a lower income neighborhood started to be like a high income neighborhood. And how it started? First of all, they introduced something like the vision, it's a creative neighborhood. So all the creatives, like crafts, all designers, graphic designers started to appropriate the space. And usually designers like nightlife. So what happened that this wave of designers, like second wave of nightlife, so start popping within these. And the neighborhood, it started to look like, oof, it's like a place where I can put my money, I can invest. So the real estate market is like the third wave, started to demolish and start to build these. And the second part, it's like the proximity to the city center. So while now a lot of headquarters, banks, they are building their headquarters there because it's like, only it shifted even the banks to build their headquarters because it's connected to the highway. It's Sharhilo Highway, which connect you at the regional level, not at the city level. So you, from your office, you can go down and go to Joni or go to the city without going to the neighborhoods. So what's happening that it's a gentrified neighborhood, and this is in urban theory gentrification. It's like, as I said before, from lower income neighborhood, it's coming like upper income neighborhood. Can you imagine the price of one apartment there? It's really hard. And it's accompanied by evictions and displacements, especially that the majority are old rents. So في كتير محاكم ببلشوا بظهروا العالم بهبطوا بيطلعوا. That's what's happening.
All right, thank you so much. We'll take one more.
Hi, Ali. Thank you for your talk. I just have a quick question. Well, first, it was good to see that, for me to understand urban planning versus when we're talking about traffic laws. I mean, everyone says traffic laws in Lebanon are there; they're just not, following. But urban planning, it doesn't seem like we actually have a plan. It looks like maybe outdated or old.
Yeah.
Could you please just comment on what you said in terms of the loss of some businesses affected generally degraded the social network?
Yeah.
What happened in specifics in Mar Mikhail along those lines? What businesses were lost and how did that degrade the social network?
Okay, what do we mean by the social network? It's the people who are living there, who are working there. So what's happening that if the rent increases, they are not able to pay more rent. So they got indirectly evicted from their place. So we can see a lot of mechanics shops, they closed, they went out, and new pubs, ACDs start to enter. So this is the replacement between my neighborhood, I live here, either as a resident or as I own a shop or I rent a shop. I'm not able to pay anymore. And even the owner, if I'm old rent, the owner forced me to go to push me up through Mahakim, all of this stuff. So the social network it's really coming degraded. And the newcomers, real estate developers, all of this stuff taking over the neighborhood. And here is questioning about the neighborhoods. It's really, what about the inclusiveness of the neighborhood, the mixity at the social class of the neighborhood? What's about the livability of the neighborhood? Because all of these, because when you destruct all these heritage buildings with these new skyscrapers and the street is so narrow and changing the density, the structure, the economy, all of this stuff. So before, a lot of neighbors were like relying on their small shops, small mechanics. It's like ecosystem in economy, If you lose these small, then you end up having an economic problem at the level of the city. Thank you.
All right, thank you so much, Ali. All right, last but not least, we have Rima Al-Hassan from the Biomedical Engineering.
Hello, humans. I just called you, all of you, humans, but I have a reason. We were here yesterday, and we are here today because we are listening to people from different engineering disciplines. Because we are listening to people from different engineering disciplines and to their projects on how to prosper the human life. At the Neural Engineering and the Nanobiosensors Lab, we are very interested in the human life and specifically in the nervous system. As you can see, the human body and specifically the nervous system is a highly complex system that travels through all the human body. But what happens if a slight error or a slight damage occurs in this system? For example, what if a person gets Parkinson, tremor, epilepsy, or Alzheimer's? The most common solution or treatment that is currently used is deep brain stimulation. This technology is basically going through invasive surgery, implanting an electrode into the brain, and giving electrical pulses to the diseased area. But these pulses actually cause the formation of scar tissue and trigger an immune response. They give a patient around 5 years, and that's it. Then the implant has to be removed. In our lab, we believe that there is another solution. There might be another solution through ultrasound mechanical stimulation. This solution is non-invasive. The device can be inserted outside of the brain. It is purely mechanical, and it has the chance to last more than 5 tissues because it does not damage the tissues electrically. But the mechanism of ultrasound treatment is not very well known, and this is why we tried to develop a mechanical model to see the effects of ultrasound stimulation on neural networks. To begin with, the nervous system is currently modeled as an electrical system. So we can see in this figure, this is the neural membrane. It is made of the lipid bimembrane, and there's ion channels, sodium, potassium, and chloride ion channels embedded in the membrane. Charges accumulate on both sides of the membrane with an insulation between them. For electrical engineering people, you would directly say this is basically a capacitive circuit. There's an insulation in between the two plates and charges on both sides. As for the ion channels, they allow the flow of charged particles inside and outside of the membrane. So thus, this can be modeled as a resistor, a varying resistor. So the famous Hodgkin and Huxley model models the neural membrane of a single neuron as follows. The capacitor shows the lipid membrane, the insulating part of the lipid membrane, and the ion channels are represented using variable resistors. As for the accumulated charges, they are represented using voltage sources. And since we have several types of ion channels, the sodium, potassium, and chloride, they are shunted in the circuit. So our biomechanical model considers 3 main components. The 3 components are the voltage-induced membrane tension. There's voltage in the membrane, and it changes during an action potential, which causes tension to vary in the membrane. The flexoelectric effect, which is basically due to the nature and the curvature of the membrane. There's oscillations that occur and cause currents to be produced. And there's the ultrasound-induced membrane tension, which we will discuss thoroughly later. These mechanical effects actually affect ion channels. They cause the ion channels to open and close or affect their normal behavior. And this is how the mechanical model will be coupled into the electrical Hodgkin and Huxley model. To begin with the voltage-induced membrane tension, when there's an electrical stimulation or an action potential traveling in the membrane of a neuron, sodium particles actually move from the outside to the inside of the membrane, and the voltage travels through the membrane. But this voltage, as it travels, it causes tension forces to appear in the membrane. These tension forces are modeled using this equation that depends mainly on the variation in the voltage as it travels through the membrane. As for the flexoelectric effect, the membrane is actually a curved structure, not a flat structure. And there's currents and voltages induced all the time and changing, which causes the membrane to fluctuate and move in a very organized manner, which causes oscillations. These oscillations induce flexoelectric currents in the membrane, modeled using this equation that depends on the capacitance, the maximum curvature, the oscillation frequency, and the flexoelectric constant. As for the ultrasound-induced membrane tension, we know that the ultrasound basically causes a tension force in the membrane where it is applied. As you notice, there are two different arrows in this figure. One has a bigger dimension because the effect of the ultrasound tension is actually greater than the effect of the tension caused by the variation of the potential across the membrane. So this is like a summary for the three main components that exist in our model that are coupled with the Hodgkin and Huxley. The red box shows the effect of ultrasound stimulation, which causes tension in the membrane. The green box shows that whenever tension comes into the membrane, it causes variation in the probability of the ion channels. It changes the energy that's in the energy difference in the membrane, which affects the probability of an ion channel, whether it's open or not. And this probability is what mainly controls the conductances in the Hodgkin and Huxley model. And then again, in the blue box, we can see that any change in the membrane voltage feeds back again, it causes more tension, it goes back into the model. So there's a feedback loop for whenever the voltage changes, there's a change in tension, and there's tension from the model that feeds back into the model, and that goes on several times. So our model studies the possibility of modulating neural networks using ultrasound stimulation. But ultrasound stimulation has many parameters. It could be pulsed or continuous. It can have low frequency or high frequency, and it can vary also in intensities. Whenever the model simulates all of these parameters and gets out the tension that comes from an ultrasound signal to the membrane, then this tension, as I previously said, changes the intrinsic energy difference in the membrane, which affects the probability of the ion channels to be either opened or closed, or alters this value. And then this probability controls the conductances of sodium, potassium, and chloride ions, which affect the firing rate and the action potential in the Hodgkin and Huxley model. So, to begin with the results, the most relevant result of our model to date is that we noticed that continuous ultrasound stimulation requires much less energy values to cause a modulation in the action potential. The graphs, they show the action potential in the membrane as a function of time. If we compare both graphs to get the same response, for the continuous stimulation, we actually required 10 microwatts per centimeter squared of acoustic intensity, while for the pulsed, we needed 5 milliwatts per centimeter squared of acoustic intensity. And this is actually compatible with some work in literature. We also noticed that at lower frequency, we require much lower intensities to cause variations in the action potential in the Hodgkin and the Huxley model. And this is probably due to the fact that higher frequencies, when the wave travels into the tissue, it tends to undergo more diffraction. But this is a theory, and we're trying to vary more parameters to check this theory. When the wave diffracts more, this reduces the impact on a specific region. And we also noticed a change in the ultrasound firing rate. So the upper graph shows the action potential when it's stimulating using an continuous ultrasound signal of 650 kilohertz, and the lower one shows 250 kilohertz. And we can notice a difference in the timing where the maximum or the spiking occurs. And this was also shown in some of published data, published experimental data. Our next step would be actually doing ultrasound stimulation experimentally. We will get an ultrasound signal, input signal, whether it's pulsed or continuous, high frequency or low frequency. This signal should go through an RF amplifier, and then it would feed into an ultrasound transducer. Once we have the signal and its properties and its acoustic properties, we could actually try the signal on an animal model, whether to the central or the peripheral nervous system, and check for electrophysiological responses. And then we would vary the parameters again. Whatever we tried, we could go through something else, and we could do the process all over again to check for each parameter what is the response of the neural network. And thank you.
Thank you, Rima. Any questions?
Thank you very much. It was a very interesting presentation, some nice work. Now, just to help me understand it a little bit more, so you're saying if you change the tension of the membrane, you change the probability of the ion channel to be closed or open. And so if you vibrate this membrane, you're changing that probability. So when we say probability, there's uncertainty, right? So how are you going to be certain that you can control the kind of output you're going to get from the cell? So isn't this what the idea is, that you want to vibrate this membrane so you can change the potential, change the voltage, change its response? Okay, so how are you going to be able to control that if it's a probability-based?
Okay. No. So basically, the ultrasound induces a specific quantity, a specific amount of tension in the membrane. But this tension is related to an energy difference that's induced in the membrane. But the energy difference is connected to the probability through a specific, very well-known formula. Whenever there's a change in the energy difference, whether due to an electrical stimulus or to a mechanical stimulus, or any form of energy transformation, it's reflected in this formula using the probability. So the probability is just not a random number. There's a dedicated relationship between the change in the energy, in the free energy of the membrane, and the probability. It's a direct relationship. I don't.
Maybe I'll speak to, maybe because it's my unfamiliarity in the field, but we can talk about this later.
Okay,
I'll leave it offline. Thank you.
Any other questions?
So thank you, Reem. This is very nice. Well, it's been long known that ultrasound radiation, it affects neuronal excitability and so on. It's been modeled quite extensively. So what's you're proposing in this right now to test it actually experimentally, doing some? What's the main idea behind actually doing the simulations?
Okay, so basically we know that the ultrasound does affect the neural excitability, but we have no idea about the specific mechanism of action or how we can actually relate input parameters to the neural network response. What we're trying to do in the model is predict for this parameter, we're going to get this response, so we could apply it experimentally and check the results. If I'm unable to tell at what frequency I need to hit this neural tissue with, to get a specific response. It might be inhibitory, it might be excitatory, and it might be inhibitory at a certain frequency or excitatory at another one. Or for the same frequency at different intensities, the response of the neural network is going to be completely different. And since we don't know how that might be, modeling the outcome would actually be helpful to limit the range of parameters that we want to use to whatever case we have.
So what's your parameters in this case?
The parameters are for the ultrasound transducer, the frequency range. If we're working for, let's say, neuromodulation, usually the parameters are between 250 kilohertz and they reach up to 800 kilohertz. So I want to limit these parameters and say for this frequency, I need that much intensity. I also have whether it's pulsed or continuous. We also have the sonication durations, intensities, and intersonication intervals. All of these are parameters that we can control to get completely different responses. They also depend on whatever transducer we are using and the tissue, whether it's transcranial or not, if there's attenuation from the tissue, or all these factors can be incorporated into the model. Yes.
So much. You talked about diffraction happening.
Yes. Yes.
Why would that happen?
Because ultrasound signals, they need specific mediums to actually travel. If we put the signal in air, it's going to be completely killed. If it's in, it passes through a skull, it behaves differently. But as the frequency gets higher, these signals diffract in tissue, in live tissue. And that's why for lower frequencies, we have better effect, or we actually, we can observe more modulation or more clear outcomes than the higher frequencies. And as we go higher in the frequency, we also induce thermal effects, and we induce cavitation, which might actually damage tissue. But that's completely not neuromodulation. It becomes ablation or any other way to use ultrasound also to treat diseases. But for neuromodulation, we prefer lower frequencies because of this effect. Between 200 and 800 kilohertz. Even 700 is more common than reaching 800. I can't hear you. I'm sorry.
Wavelength in this case, when you're penetrating in the soft tissue.
I mean for the tissue. We currently, the thing is that we don't know how the ultrasound affects the neural membrane, or how all the studies have been how this neural network functions electrically. No one thinks of the neural network as a mechanical network, or maybe the ultrasound, the electrical is caused by actually mechanical signals. So this information is something that we don't know yet.
Any other questions? I have a lot of questions, but I'll catch you offline. I'll catch you offline later. All right. Thank you so much. Thank you, everyone, for attending. There's going to be ideas talks starting at 12 here, and we have some really interesting talks by a lot of professors from AUB. It's kind of like a TED Talks, and they're going to highlight their research in really interesting ways where people from all over could really get, understand what they do. We also currently have the Maker Fair, which is happening in the Big Tent on Bechtel. Please check that out. We have people or societies presenting their work, and then some of their personal projects as well. Other things are happening. We also have the alumni mixer starting at 2, as well as the startups demo day, and that would start at 3 o'clock. We have a lot of final year projects competing to get some funding to start up their own companies. So please do that. And then finally, we have the closing ceremony at 6:30, and a lot of awards would be given, best presentation, best posters, and all that. So whoever presented and the audience, please be present there. There's also going to be really good food as well. So see you guys later, and thanks for coming again.